Hello everyone, myself is Salim Akhtar, physics teacher, and yesterday we have discussed about the Coulomb force and superposition of Coulomb force. Now in the lecture number 4 we shall discuss about some important questions and numericals based on Coulomb force and superposition of Coulomb force. The few questions are written on the board, and the first question is define SI unit of charge. And it is also asked 1 Coulomb charge to define. So in question number first, we know the formula. The answer of the question number 1 is F is equal to, for the vacuum, K Q1 Q2 upon R square. If we consider Q1 is equal to Q2 and R is equal to 1 meter, and in vacuum the value of K is 9 into 10 raised to the power 9. So the value of F is equal to, in the formula, 9 into 10 raised to the power 9 into the value of Q1 and Q2 is equal to 1 Coulomb. We shall consider 1 into 1 upon separation of charges is 1 meter, means 1 into 1, and the total answer is 9 into 10 raised to the power 9 Newton. Means the definition of 1 Coulomb charge, or the SI unit of charge, is what? When two equal charges are separated 1 meter in vacuum, then if the force between the charges is 9 into 10 raised to the power 9 Newton, then the magnitude of charges is called 1 Coulomb. Again I am repeating, when equal charges are separated by 1 meter in vacuum, and they repel one another by 9 into 10 raised to the power 9 Newton, then the magnitude of charges is said to be equal to 1 Coulomb. Again I am repeating, when equal charges are separated by 1 meter in vacuum and they repel one another by 9 into 10 raised to the power 9 Newton, then the magnitude of the charges is said to be equal to 1 Coulomb. This is the value of 1 Coulomb. And the question number 2 is define dielectric constant of medium. The dielectric constant of medium for the answer of question number 2. Now we shall write just like this. Dielectric constant is nothing but it is the relative permittivity, and we have discussed about the relative permittivity. Answer of question number 2, dielectric constant, and it is equal to relative permittivity. And relative permittivity is denoted by epsilon r, and dielectric constant is expressed by K sometimes, and epsilon r is equal to epsilon upon epsilon naught, permittivity of medium and permittivity of vacuums, and the other expression for the relative permittivity or dielectric constant is F0 upon Fn, Coulomb force in vacuum and Coulomb force in medium. So the definition of dielectric constant and relative permittivity, it is the ratio of permittivity of medium to the permittivity of vacuum. It is unitless and dimensionless quantity. It can also be defined as the ratio of Coulomb force between the charges separated by certain distance in vacuum to the Coulomb force between the same charges separated by same distance in medium. And we have, I have given you the definitions of Coulomb relative permittivity in the previous notes. So it is the definition. I am again writing the ratio of relative permittivity the ratio of permittivity of medium to the permittivity in a vacuum is called dielectric constant or relative permittivity. The second is the ratio of Coulomb force between two charges separated by certain distance, in vacuum to the Coulomb force between same charges separated by same distance in medium. Again, I am repeating the ratio of permittivity of medium to the permittivity in vacuum is called dielectric constant. The ratio of Coulomb force between two charges separated by certain distance in vacuum to the Coulomb force between same charges separated by same distance in medium is called dielectric constant. Dielectric constant or relative permittivity. This is the answer of the second question. Now we shall discuss about the limitations of Coulomb force. Limitations of Coulomb force we also discussed in the previous step. Third, the limitations of Coulomb force, and we shall discuss about in previous lecture also. The limitations of Coulomb force, there are certain limitations. Number first, both charges should be pointed. The first condition should be pointed. The second condition is both charges should be separated by finite distance. If the charge is separated at infinite distance, then the Coulomb force or Coulomb's law cannot be held. And the third one is both charges should be stationary. For moving charges, Coulomb force never holds. So these are the few limitations, certain limitations of Coulomb force. Both charges should be pointed. Second, both charges should be separated by finite distance. And the third is both charges should be stationary. This is the answer of the third question. Now we shall move to the question number 4, that is Coulomb force is a central force. Why? Central force is the force in which the force is the function of position. Answer of question number 4, because Coulomb force F is inversely proportional to R square, separation of charges. And in this separation, the separation is the distance between the centers of the charge bodies, and that's why, because it is the function, Coulomb force is a function of separation of centers of charge bodies so it is called central force. So Coulomb force is called central force. So the Coulomb force is a function of the position or separation of charges, that is, it is the separation between the centers of the bodies, or Coulomb force is a function of separation of centers of charge bodies. So Coulomb force is called central force also. This is the answer of the question number 4. Now we move to question number 5. Draw curve between Coulomb force and separation R. Coulomb force is directly proportional to R. It is directly proportional. It is the curve between force and separation of charges, square of separation of charges, and it is 1 upon R square. So first of all, we know that F is inversely proportional to, this is the answer of question number 5. F is inversely proportional to R square. First of all, we certain rules we have to understand. The fact that if F is inversely proportional to Rn, and if n is equal to 2, 4, 6, 8, dash, 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 means even powers, then the shape of the curve will be parabola. And if n is equal to 3, 5, 7, 9, means odd number, the powers are in odd numbers, then the shape of the curve will be hyperbola. And if n is equal to 1, then it will be a rectangular hyperbola. A rectangular hyperbola. And if F is directly proportional to R power n, and if n is equal to 2, 4, 6, 8, dash, 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 then the shape of the curve will be parabola. And n is equal to 3, 5, 7, 9, dash, 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 then the shape of the curve will be hyperbola. And if n is equal to 1, means F is directly proportional to R, then the shape of the curve will be straight line. So for this respect, if we determine or if we want to draw the curve between F and R, means here F and R case, this is F and this is R, then the shape of the curve will be R square, because the Coulomb force is inversely proportional to R square, and here the power is even number, so the shape of the curve will be parabola. So the curve between F and R will be parabola. And if we want to draw the curve between F and R square, means F is directly proportional to 1 upon R square, and this is the power. So the shape of the curve will be F and R, and it will be the hyperbola. And if we want to draw the curve between, this is for A, this is for B. For first, the answer will be parabola, and for second, the answer will be hyperbola. And for the third, if we want to draw the curve between F and 1 upon R square, because it is directly proportional to 1 upon R square, so the shape of the curve will be straight line. Shape of the curve will be straight line. So for the answer of a curve between Coulomb force and R, it will be parabola. Force between F and R square, it will be hyperbola. And force and 1 upon R square, it will be straight line. Again, I want to explain some things with respect to these questions, because F is equal to K Q1 Q2 into 1 upon R square. This is the equation of Y is equal to mx. Y means F and x means 1 upon R square, means K Q1 Q2 is the slope of curve. K Q1 Q2 is the slope of curve. If for the vacuum, the value of K is greater, for a medium, the value of K is smaller. And if the product of charges is greater, then the slope is also greater. And if the product of charges is smaller, then the slope of the curve is also smaller. So if we have to draw the question, we have to draw the curve for the different sets of and different conditions. First of all, we draw F and 1 upon R square. And in this case, if we want to draw the curve for vacuum and medium, then this curve is for vacuum, because the slope of this curve is greater, and for the medium, this will curve, because the slope of this curve is smaller, because the value of K for vacuum is greater than the value of K for medium. Because Km is equal to K0 upon epsilon R, relative permittivity, divides the medium, K for vacuum, then we can obtain the K for medium. And if the product of charges for 2 and 3, and we can take the example 4 and 7. The product of these two charges is 6, and the product of these two charges is 28. So the product is, this is greater, so the slope of this curve will be greater and slope of this curve will be smaller. And in this case, here is the slope and this is the curve. This is also F and 1 upon R square, and this is for 2 and 3 charges, and this is for 4 and 7 charges. This is for all, both the charges are positive. If we can consider the negative charges, then the shape of the curve will also be same. And if the charges are opposite, then the force will be attractive and the shape of the curve will be this type. Like this is the curve for 4 and 7 and this is the curve for 2 and -3. This slope is smaller, this slope is greater, and this is the attractive force, this is the repulsive force, this is force, and this is the curve for 1 upon r square. So these are all about the curve we can plot, and it is an important question for the board examination.